Welcome back to Workplace and Apprenticeship 30. We're continuing on today with the sign law, which is section 7.1. So first of all, how do you know where to put the lowercase letters and the capital letters? So we have actually the lowercase letters are always the side lengths and the capital letters are your angle measures. So we can set it up in our sign law. Remember that the sign law can also be flipped. You can have sign A equals sign B equals sign C on the top with A, B, and C on the bottom. So here we have a triangle that is all solved for us. So let's show that the sign law really does work by putting these into our ratio and figuring out if they're all the same. So if we have 5 over, and what should be paired with the 5? Good, so sine 33.5, and that should be equal to 8 over, what goes with the 8? Good, 62.2, because again, they're across from each other. And then we have a 9 over sine, made a mistake there, nobody caught that? Sine 62.2 and sine 84.3. So you'll find here that they all equal roughly 9.04. This one is slightly off, and the reason for that could just be rounding of your angle measures. So then we're going to look at example 1 on page 251. So last day we didn't work with word problems at all, and today we're all doing word problems. Don't forget that you need to always draw your triangle. So every single time you need to draw your triangle. Here we have Andrea as a machinist. She must program a laser cutter to make a triangular hole as part of a diamond-shaped grate she's making. The triangle is isosceles. So here we have an isosceles triangle. 2 of the legs are 8.4 centimeters. And 2 of the angles are 28 degrees. We want to find the length of C. So let's label this part C. So we need to set this up using the sign law. Brianna, how could I set this up? And Brianna has set this up correctly. This is what she got. Note that you needed to find your other angle measure before you could actually carry this out. So to find this other angle measure, we went 180 minus 28 minus 28, since all 3 of the angles have to add up to 180 degrees. So we get a total of 124 degrees for our last angle. And we also get side length C to be, I got 14.8. 14.8 centimeters long. And let's look at example 2 on page 252. Here we have a helicopter that can be seen at an angle of elevation of 68 degrees. Now remember that, if this is your eye and this is your sight line, your angle of elevation would be looking up. Your angle of depression would be looking down from that line. So here we have our angle of elevation is 68. We have 450 meters between the helicopter and the base camp. And we have from the surveyors to the helicopter is 1,200 meters. So we need to draw this. All right, so this is what your drawing should look like, where you have your base camp, your helicopter, and your surveyors. We can then set this up using the sign law. Remember with the sign law, we always cross multiply. So we'll end up with 450 times sine 68 equals 1,200 times sine x. To get the sine x by itself, remember that the sine is always stuck with its angle. So we divide just by 1,200 to get sine x equals some small decimal number, 0.34. Good. Now to get x, we need to actually go the inverse of sine or hit the second button on your calculator to get the measure of angle x to equal approximately 20 degrees. Good job. So mental math and estimation. Here we have a triangle. It's supposed to be of 2 security cameras to view the corner of a room. We have one angle is 46 and the opposite side, or the side across from it, is 7.9. Then we have another angle, it's 44, and we're trying to determine approximately what the side across from it would be. not using any calculators. So here, note that 46 and 44 are very close to being the same angle, and since this pair set up as 7.9 over sine 46 should be equal to the other pair, which is b over sine 44. We know that a and b should also be very close to the same. However, since 44 is smaller than 46, b should also be smaller than a. So we could take approximately 7.7. So then we're going to move to discuss the ideas. Property perimeters. Gersh is thinking about fencing the property shown in the diagram below. So she estimated the distances shown on the diagram. So she's estimated all these distances. We want to calculate the perimeter based on this. Do we have enough information? So yes, this is possible. We need first to determine this angle. We know that this, since it's north, south, east, west, it's going to make a 90-degree. Since part of it's 45, the other part must also be 45. And now we have a side length angle pair that are across from each other. So we can use the sine law to find angle B. So to set this up, we'd go sine 45 over 413 equals sine B over 325. You're looking again for the measure of angle B. And the measure of angle B you should find is about 34 degrees. So if this here is 34, we're really trying to figure out this whole bottom side length, part C. So we need to have this other angle first. We know that all three angles add up to 180 degrees. So 180 minus 45 minus 34 is 101 degrees. So now we can set up sine law again. We'll go sine 101 over C equals sine 45 over 413. And we should find side length C, after we cross multiply, to be about 573 meters. Now, last but not least, they're asking us for the perimeter. So the perimeter is we have to add up all of our outside side lengths. So 573 plus 325 plus 413. So our total perimeter should end up with 1,311 meters. So now we're being asked if angle A was actually a 90-degree angle, would our sine law still work? So to set this up, I'd end up with sine of 90 over A equals sine of, and we could choose any of the other angles, B over B. If I were to cross multiply here, I'd get B times sine 90 equals A sine B. And I'm trying to figure out sine B. I want that by itself. So divide both sides by A. What do you get when you type sine 90 into your calculator? You actually get 1. So we'll get B times 1 over A equals sine B. So B over A. Now if you look here at this angle, the opposite of this angle, of angle B, the opposite would be little b, and the hypotenuse would be A. So if I were just using sine theta, I'd get opposite over hypotenuse, which is exactly what our sine law came up with. So really, this is the same as sine B equals opposite over hypotenuse. And therefore, yes, you can use it with even right triangles if that's what you prefer to do. So then we have an assignment on page 254, numbers 1 to 7.